we're calling it active temporal resonance. So resonance is how you change the weights of a memory. So current state, it's a frequency and recency. So like the most recent memories get a bit more weighted, and the more often, so the frequency. We added different dimensions to that. So now think of, even if you don't retrieve it, if you're talking in a topic that's adjacent to it that may influence it, like how frequent it is, or just the subject matter may have impact on it, we can change that other dimension. Backboard is your entire AI stack in one API, and the world's smartest AI memory.
Gotcha.
Yeah, so that's what we've built.
Okay, so what do you mean by the world's smartest AI memory?
So we actually set out to build like a whole layer to manage state. So your thread management and your conversations, and then your RAG, which is different, so your access to data through an LLM. And we were going to put so we use other LLMs, your LLM independent, all in one, kind of like a configuration layer. And we weren't looking to build like a business out of it. We're just like built some dev tools because we wanted to build for the builders. And then when we looked at memory, a lot of them are open source, and we kind of looked under the hood, and like in a very un-Canadian-like fashion, we're just like, everyone's doing it wrong, and like we have like an incredible engineer, and from the new school, and I'm from arguably the very old school, and kind of put our heads together. It's like, what if we did this, and what if we did that? So we wrote our own memory system, and we're inspired by current founders in the ecosystem, even in the Ottawa ecosystem. And we just built it, and we tried to baseline it. And so
you beat some benchmarks, right?
So yeah, so we just like wanted to see how good we were doing. So we grabbed the industry benchmark, Locomo, ran it, and it broke all the records. So it was like current state, it's about 68% accuracy. Ours is 91 on our first try. Thought we did it wrong. And so we redid it, and then we reached out to our friends at Queen's University to independently look at it. And like, yeah, we did it right. And we've since optimized. So we broke all the records, and then we published all the results. We open sourced the script to repeat it. But we're an API company, so anybody can repeat it at any time. We've since improved it. There's another big benchmark as well, and we just broke that one as well. So no other company has broken all the benchmarks.
So it sounds to me like you guys are all in on memory, which is quite interesting to me because like just a couple months or even a year ago, like RAG was like the next big thing. Like Pinecone was doing like 100 mil AR, and now like I mean they're not there anymore. But I started to hear more conversations around memory, especially around the self-learning memory mechanism, especially like when it has to do with like agent skills and stuff like that. So why memory? Why not RAG when you guys were first kind of like diving into the space?
It's a different thing. Like, so state is not RAG, and RAG is not memory. So state management is just controlling and storing and retrieving your messages in one conversation. RAG is just your interface with data, whether it's structured or unstructured. So we consider RAG as kind of like a rule set that's static, and you can change it on the fly as well. But like, it's just your rule set that's static. And then memory is different. So memory we see as something. I think when it comes to digital memory, I think the metaphor of the human brain fails. And everyone just got so caught up in knowledge graphs, and which I think is a gimmick right now. I'm gonna get in trouble for saying that, but like I just think it's a gimmick. It might be an optimizer, but the bigger companies who have tried it are moving away from it. And I don't think, yeah, like the metaphor of like the human mind, like the human mind is very efficient. One of the reasons it's very efficient is that when we go to sleep, we delete memories. Right? We passively curate them. So we store the memories that we think we should know, like run away from tigers, and then we forget the ones like that we don't want to know. So like you talked with a guy with a white shirt, he was very uninteresting, you forgot his name, you just don't think you need to remember it.
Yeah, so touch on that a little bit more. So what I'm hearing is that there are different types of memories, right?
Yeah.
There's the kind of memory that you use to like go about your day and then do your work and whatever. And there's like almost like the long-term memory where you can like recall at the right time to do like certain tasks. So like from your perspective, like how many types of memories are there?
Um, a lot of different types. But to go back to that example, though, like if we wanted to if we met up with that same guy that we decided not to remember his name, but you embarrassed in the moment, your mind will actually hallucinate. It'll create it. You'll be like, I thought your name was Alex. It's like, no, that was Chris, right? So
What's it
like
called,
we
the
actually
Mandela
recreate it.
effect or something?
Yeah, that's a different thing, I think. But like with digital memory, it should always be there. It's storage, right? Like memory should be 100% accurate as a baseline. And I actually argue that AI memory should be 120% accurate, right? So when we're storing information on behalf of like a conversation, you have the topic context and the subject. You have user preferences, you have user context, you have life context when you're storing it. So you can enrich that storage. When you retrieve it, say it's 2 years later, everything's changed. You're likely asking to invoke that memory under a different topic, under a different user preference, under a different user context, under a different world context.
Right.
We should call that out, right? So like you should be returning 120% accuracy. And I think that's very doable this year.
Why this year?
Because things go so fast. And I think I want to say we're almost there. Like we're at the 94 to 96% accuracy with the benchmarks and all of our internal evals. I think we broke the evals, and I think we know how to enrich the data.
That's fair.
Yeah.
So when we work on RAG projects for our customers, typically the problem is not the LLM. Typically it's like your retrieval pipeline, there's something wrong there. Maybe like the query that's coming in doesn't have enough context. Maybe the data is not there in the knowledge base.
Yeah.
Or maybe you're embedding models and some weird stuff happening there. So I know you guys have a pretty cool decision, made a pretty interesting decision where you basically wrap the entire LLM call, and then, as soon as the moment that the user's query comes in, it goes directly to Backboard as opposed to like going to an LLM kind of like expand the query and go to like a retrieval system, but you take over as soon as the user's query comes in. So how much of the work is on the LLM, and as you said, this year LLM's going to get better over time. Yeah. Does that matter for memory at all, or?
Well, so we are exposing more, so both will be true. So we do have the orchestrator, so you can just throw a bunch of information at us, and we'll decide what is worthy of storing based on your configuration. But we also allow for side loading, so you want to force the storage, we'll do that. What was the question?
Yeah, so like as LLMs get better over time, especially now we're hearing that Sonnet 5 is going to come out in a couple of days. Yeah. GPT 5.3 just came out as of like a couple hours ago. So like, do those things matter when you build a memory, or is the memory stack kind of like a different set of problems altogether?
So we do use versions of LLMs in our orchestrator, so that makes by default that it better for sure. And like, there are so many different approaches to memory now that it's almost a solved problem, but it isn't. But it's feeling like there's going to be many ways to get it right. Right, and there's pure vector plays, there's pure flat files plays. Like Letta's got a great paper on that, kind of like tongue in cheek. But like, I think, yeah, like we have our like knowledge graphs that people make, reference to that, and like, yeah, Simon's doing his thing too, right? with special indexing and stuff. Like, yeah, that stuff is all really inspiring. Just discovered two today that a VC showed me. It's just, they're completely new approaches. So the answer is yes. Like the LLMs are going to get better if they're in the right place and they're tooled properly. They'll get better. But our memory system is completely independent of that. And like we are exposing more and more configuration points because a lot of devs want more configuration. We started with memory equals true, and then it just works.
Yeah.
But they want to control a lot of the things. They want to control how it's called. They want to control the embeddings, the dimensions, top K, like all those things. Like,
do you find it so that people want control over when it's called, when it's invoked? Because I know with Anthropic, there's like a, no implementation, but a spec for like a memory tool that you can call for the model.
Most of them actually force, like, it's very manual. Very few actually have full orchestration. So like I know I'm not going to mention them because they're a competitor, have one and they charge through the nose for it. We just by default we try to keep the prices low as possible. But yeah, most of them are just like you decide like as a developer you have to decide when a memory is a memory.
Gotcha.
Yeah.
Are you guys thinking about long horizon tasks for agents, kind of like CloudBot or I guess Moltbot now?
Yeah.
Are you thinking?
OpenClaw now.
Oh yeah, I can't even keep up with it. It's OpenClaw. Yeah, you're
Yeah.
right. And are you thinking about like building for that kind of agent where it could be running for maybe 30 minutes, an hour, 2 days type deal, and like performance degrades as it goes because it doesn't clear its own context?
So maybe it's my age speaking, but like OpenClaw had a lot of security vulnerabilities, and like we just went through, our SOC 2. We take it very seriously. My background is compliance. Maybe that's my mind talking, but like we did fork an OpenClaw version, but like we were late to the party because like I don't want to expose people's memories because that's their personal data, and like it's a difficult thing to mitigate. I don't want to expose their regular user data or their keys, and like all of those things have been exposed in plain text, right? So we do have an OpenClaw Claw Hub, they call it, our skill. So that we just published that yesterday, but like I'm security led, so but to answer your bigger question, yeah, absolutely. Like I think like self-learning, like recursive self-learning is a part of that's the next generation. I just want to be careful with it.
Yeah. How are you guys thinking about like self-learning for your memory stack?
It'll like, so we talked about it a lot. So it's a different dimension of orchestration. So we have the orchestration that just essentially just decides this is a good memory and this is how we should store it and this is how we should enrich it and retrieve it. But we have another orchestration that looks at that, and that could be run just in parallel, so it doesn't screw up latency. But like, it has to decide those things, and so and then you get into: are you going to like recode your agent? Dangerous. Are you going to reprompt your agent? Dangerous. So like, yeah, I think that's the ultimate goal for like everybody, and I think that would be incredibly powerful. I think OpenClaw has done that. But again, go back to security. Like, if you want it to be that powerful, you're going to have to give it your credentials and power over, your online presence. So
for sure, yeah. What about OpenClaw is obviously on the other end of the spectrum, which is like very tinkery, kind of like enthusiast kind of open source project. But so far, like we know, long horizon running tasks and agents have done a better job in terms of like better performance, higher accuracy, and can tackle more complex things closer to what a business would need. So something like deep agent from LangChain or this sort of background agent. So like, do you see the Backboard stack kind of like cater towards that crowd at all?
So one of our go-to-market is really we sponsor a lot of hackathons, and seeing what these guys build like in 3 days would have taken us years ago, and it just reminded me of one of the projects is that in order to get their system working, they used 6 different agents with 6 different LLMs, and they were completely optimized. I see a swarm of agents being able to handle long horizon much better, right? And then you can evaluate which ones are going off the guardrails.
Is that because of context management, so that you can like have the main agent kind of offset the context to like the sub agent?
Yeah, and some contexts, like the use cases are specific to that LLM, right? We all know LLMs are specialized. So, and I think the future is going to be, SLMs that are hyper specialized. So Claude's going to be good at coding, and Gemini's going to be good at this, and Grok's going to be good at that. And so you can tool that. Yeah, that's, and to not shamelessly plug, but that you can do all that through the Backboard API.
That's fair. Yeah. What is like the most interesting thing or most exciting thing that you guys are working on right now that you can share?
So, I mean, we're doing some pretty cool things. I mean, we're building a marketplace. Like, I think that's just, it's natural because we have got like hundreds of projects from these students that may want to take it to the next steps, getting them, angel checks and helping them along their way. That's more formulaic than anything. Like, I don't know, like my head engineer has an idea that will render all of our current tech obsolete. And just the nature of the beast. Like there are things where there is where the puck is going. Like, we know the fine tuning costs are going to come down. We know prompt baking exists with CAMS paper. Like, there's just so many cool new tools out there that.
Are you guys thinking about like agent skills at all?
Agent skills? Like, how do you mean?
Do you put out skills for Backboard so that developers, when implementing Backboard, have an easier time doing so with the best practice that your team has decided for them?
Yeah, kind of. We haven't like regimented it. Right now, it's like it's going to be projects that they want to build. We're going to have like an open source project. So like a lot of these kids out of school can build open source on Backboard. We'll pay them for it. They get shipped code. They can add to their portfolio when they enter the workforce and stuff. And it also like for us, it really demonstrates the potential use cases. Like, there's stuff that these kids are doing that blows our mind. Like there's the one kid, sorry, they're adults and they're in university. This group out of U of T or Waterloo, I forget now. It's called Chorus, but they built this pretty much a voicing agent for nonverbal. And so like it gets to know you over time, and it just needs to exist in the world. So like, and it actually has a voice, and you can put tonality, answer this like I'm happy, I'm angry, whatever. And it gets to know you over time because they use their memory. And so someone asks you a repeated question, it'll actually show you the answer, and they just have to tap. So like we ran this by, there's a comedian, Aaron Belisle. He's got cerebral palsy. So he's a Canadian comedian. He's excellent. John went out and just reached out and showed him. And he's like, this would change my life and change my career. And so, yeah, just want to make that happen. It's like just one of the many, like, Omnicast, like the group that won, I think, the McGill hackathon. You remember Notebook LM, like the podcast thing? Same thing, but you can actually interrupt it and have a conversation.
No way.
Yeah. So you're
cool.
a part of the podcast. Yeah. Yeah, they won.
Obviously.
Yeah, no, legit. And there's another McGill guy who's just Model Forged that won the pre-hack. He's fine-tuning in like 6 minutes, like actually changing weights and models. So like, yeah.
Incredible.
Yeah.
So what are some of the use cases that you've seen so far since the beginning of Backboard that is more, I'm guessing like from business friendly, that businesses have kind of like realized the value of it? Like how important is memory for, I guess, the AI stack for like businesses?
I'm surprised. Like we still lead with, I mean, it's the entire stack in one API, and we because we built the memory and because we're very, very proud of it, like we lead with it. Our biggest client really like they came to us because they love the state management over multiple LLMs. A giant company, they're just like, yeah, the memory's nice and we'll probably figure out how to use that. But they really wanted state management. They just want to be able to be in a room. We actually have this one project, it's an LLM council. There's like, you can create any council member, give its persona and LLM.
Nice.
And then you can give it a topic and it'll deliberate and tell you its consensus score. Like that's the type of stuff that they're using it for. Second biggest client is a giant telecom company. Customer support, that seems to be a common use case. Mm-hmm. But their memory just couldn't work fast enough. And so like while they're getting the incoming call, they're drawing the memory and summarizing in real time. So by the time they answer the call, it's on their screen. And you can tool it to be like, former interaction or last interaction was irate. Now how do we deal with it? And then there's like happy customer. And now they're sideloading the promos and stuff, and they're using the RAG part of that to sideload the promos, so it just checks. Just solid use cases.
Cool. So what I'm hearing, I hope you would kind of reveal some of the the inner workings of like the backboard stack here. But what I'm hearing is there's the memory component to it, but there's also like you guys also tackle like the RAG part of it as well.
Yep.
So there's the retrieval part, and then there's also like the memory part, which I'm assuming, and correct me if I'm wrong. There's like the entity extraction stuff where it's like you selectively remember certain things, and then there's like the memory for the conversation thread, where like the customer support kind of AI can be like continue the conversation until the session ends. How much of that can you reveal? Can you kind of paint a picture of like how does the backboard memory stack work on a high level?
So yeah, we have a paper written. The investors don't want us to publish it, or if they do, have to redact some things. But we're calling it active temporal resonance. So resonance is how you change the weights of a memory. So current state, it's a frequency and recency. So like the most recent memories get a bit more weighted, and the more often, so the frequency. We added different dimensions to that. So now think of, even if you don't retrieve it, if you're talking in a topic that's adjacent to it that may influence it, like how frequent it is, or just the subject matter may have impact on it, we can change that other dimension. So there's like another way. And same thing with the world context. Like we can do that active. This is where the active part is.
What is the world context?
So if you're talking about, I guess, Kobe Bryant, and then you're saying, yeah, no, he's my favorite player. I can't wait to go see him. And then the world context, something, he died in a terrible crash.
Would that be like a tool call to kind of like go do like a general web search of some kind?
Yep.
Okay.
Yeah. So like you're influencing, world events are influencing your actual memories, and that's what I mean by enrichment, right? So like that. Yeah, that's kind of what I mean for world context. Yeah, and that's the active part of it, is it's happening in the background. We haven't decided how frequently. It's like a daily batch now, but like, yeah.
That is super cool. I like that approach because, as my agent remembers a bunch of things about me, maybe I mentioned technologies that just came out.
Yeah.
I would love for it to proactively go and research those things and be like, okay, now I have an understanding of like what this guy was talking about.
Yeah.
Because I just looked it up.
So like you think of it as like just another human assistant that you're talking to, and like it has a photographic memory, and they're out in the real world. They know you have tickets to the Lakers game. They're going to come at you be like, hey, sorry, Laker game's canceled.
Yeah. So that's like
really sad example. Sorry about that.
and in case people don't know, like you're really into sports and basketball.
I am.
Like really, really.
I don't know if you can tell.
So that's for like examples of like things that are like kind of like in the open web, mainstream information. But what about like proprietary information? Let's say like I have a source of data that is proprietary. Let's say I'm like BlackRock or I don't know, one of those companies, and I have a knowledge base of concepts and things and ontologies that are like specific to my organization.
Yep.
Can I plug that in, or?
That's a brilliant question. That's a perfect use case. Yeah. I was talking to a friend who is a VC, and a great VC, and it's just like we want to build a VC in a box, because they have all the your investment memos and all the decks, and if you want to pull something from your deck, and then you want to plug in your emails, your conversations, your meeting notes, your meeting transcripts, I'm like, yeah, they want to draw from that for sure. And then you have something adjacent come in, like that may or may not resonate. Poor pun there, but that's an exact use case, right? So like the real world could be the organization. That's another reason for our architecture with the memory is independent. So with your VC crew, you're having conversations with your LLM, and you're creating memories and stuff, and then so is your colleagues. And if one of your colleagues leaves, you're going to lose that memory. But if it's in the organization, you might as well keep it. But panning out, you want to look at trends with everybody's memories, right? So now you can look at it from a CEO hat, be like, okay, what is going on? And that's where you can have like the third-party organization stuff can scrub it and coming up with different insights.
That's fair. Does that require a knowledge graph of some kind?
It doesn't. Nope. Tell
me more.
it's a it's a way we index. There is vector involved for sure, but there are other texts. There's a couple of new texts and there's one very old tech, which is just make sure you're normalized. And that's an old school term, but like it's gotten lost with this new generation of indexing and and storage and stuff. And yeah. That's as much as I can give away, because you want to keep it fast and you want to keep it like the temporal stuff is really difficult for LLMs, as you probably know. Like that's the hardest benchmark to beat. LLMs intrinsically have a trouble telling time, and so there is no SLM that exists that actually figured it out. So time differentiate, all those type things, so. That's a difficult one, and we solved it with indexing.
Yeah. So in the perfect world, this is one of my last questions. In the perfect world, what kind of products or AI agents or technologies or software do you think companies or organizations should be building with stuff like Backboard?
Just because this is going to sound self-serving, but because we're just so focused on accuracy, because we think it's just the most important thing. I think organizations should pay attention to that. Healthcare, you should get it right every single time, right? And defense, you should probably get it right every single time. So I think they should be incredibly thoughtful, and this is why we say memory should be the first primitive. Right? When we used to build software, we built the database first, right? We designed it schematic, we actually had it normalized. Then we build the software, and for some reason we don't do that now. Right now we build a systems because we're so excited to chat with an LLM, and then we build data storage around it, and then you end up with these weird gimmicks that just don't store properly. So it's digital memory. It's all just software, and LLM is just a file in a server somewhere. It's not out to get us. It's not thinking.
Yeah.
Right? It's just a file, right? You're rubbing some Python script against it, and you input data, output data. That's it. For some reason, people lost track of that, so I think memory should be treated like digital storage, proper.
That's fair. What are some of the exciting things that you have on the near horizon right now? Are we expecting new releases or anything like that? The paper you mentioned.
So, we got the papers coming out. We're releasing something called Switchboard, which I should share with you right away because it's an alpha. And what that is based on, so we have two versions of evaluating an AI stack, a tech stack. So the first is you can pick any of one of our 17,000 LLMs or a bunch of them, and you can configure them any way you want. And then you run a question. My default question is, what's the capital of Paris? And then the golden answer, Paris is not a country, should be the golden answer. And you test the LLM, you can test the embedders, you can test dimensions, you can test all of these things, you can configure them all, and you can run them in a virtual way. And it'll return the potential token use, the cost, and the latency based on current benchmark data. But we can also do is you can run an empirical one, you can run a live one. You can upload your own eval, so you can upload your JSON file, and then you can test out your stack in real time. I'm going to keep that as free as possible. And then the third version, so that's in alpha now, so I can send it to you, probably be out by the time this is out. And the third part is we want to be able to recommend stacks, right? So we want to go into natural language, tell us your use case. If you want to write, give us your eval, whatever. And then we'll say, these 5 stacks based on, your sensitivity to accuracy, to cost, per latency. You can even extrapolate to carbon output if you want. And it'll give you the stacks and then you can test them in real time.
Cool. Yep. Well, Rod, thank you so much for your time and thank you for showing me this amazing office with the cool decors. You guys have been here for a month, so.
Yeah, still pretty new. Yeah, appreciate you, man.
Absolutely.
Cheers.